Good day, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about normality plot. Without further ado, I'll share my computer screen with you. Says, let me, yeah, that might be better. Test whether the following data set follows a normal distribution, 102, 105, etc. If you count the number of samples and the number in the sample size or number of data points is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and for 15. N is equal to 15. Okay, so let's solve this problem. Solution. So the numbers are already arranged from lowest to the highest. Okay, as you can see, they're arranged in ascending order. Okay, N is equal to 15. N is your sample size. Okay, so we are going to spread the values evenly over the interval 0 to 1, 0 to 1. Okay. This is done by, so this is done by assigning the value one over 2n equal to 1 over 2 times 15 or 1 over 30 to the first sample point. Sample point. Okay. Okay. The next one, the next sample point will have the value 3 over 2n or 3 over 30. Okay. And so forth. 3 over 30. And the next one, 5 over 30, followed by 7 over 30, and then dash, 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 dash. Okay. The last one will be, if you continue in this manner, the last one will be 29 over 30. Okay. So let's make a table now. Okay. So let's make a table. Okay. So we are arranging the numbers from the lowest to the highest. Okay. So okay. So I'm making a table. So my table is I is I means what number point it is. then xi, and then ai. Okay, so my first point, as we see, is I is 1, okay, and xi is 1 or 2. And we have assigned it the value of 1 over 30, which is 0.033. Okay, so xi, ai. The next point is 2, is 105. 105. And let me make this a better table so that there is no. So let me erase all this and I will do it again. So if I have I values, and then I have xi values and ai values, and this will go down. Okay, so we have 15 data points. So the first data points is I is 1, is 1 or 2, and ai is 1 over 30, which is equal to 0.033. Okay. Next data point I is 2. Second point is 105, is 3 over 30, which is 0.1. Next one is number 3, is 113, and that will be 5 over 30, which is equal to, I'll write the decimal values moving forward. 5 over 30 is 0.167. Next one, number 4, is 120, and its decimal value is 0.233. Then number 5 point, it's is after the one after 120, is 125, and its decimal value, it is actually 9 over 30, which is 0.30. Okay, then number 6 point is after 125. This is 125. Next one is 127. 127, and its decimal value is 0.3663. Okay, let's get some more space. Okay, then we have 7, 8, 9, 10, 11, 12, 13, and some more space is needed. 14 and 15. We have 15 data points, remember? So let's start with number 8 after 127 is 134. First I will list the point, then 135, then 139, then 141. Next one is 144. So here you can see it's a little bit of mistake, so I'll create this. So number 10 after 135 is 139. Okay, number 11 is 141. Next one is 144. Then it is 145. Then it is I missed something. Did I? 135, 139, 141, 144, 145. Then I have 149 actually, and then 150, and then 160. Okay. So 134, the decimal value is 0.433. Next one is 0.5. Next one is 0.567. Next one is 0.633. Next one is 0.7. Then it is 0.766. Then it is 0.833. Then it is 0.9, and the last one is 0.967. So I've assigned these values. Okay. Okay. So these AI values, so if I create a little bit of space, so basically these AI values, okay, these values, AI values represent the areas under the normal curve. Areas under the normal curve in the left tail. Curve in the left tail. In the left tail. Okay. We can use TI-84, TI-84, then second key, worst key, and number 3, in norm, which is in norm, and use these areas use these areas to find the corresponding z-scores. Such that the area to the left of the z is equal to the AI value, is equal to the AI value. Okay. Okay. So let's plug in so if I go up a little bit, first of all, let me change the color of the ink. Okay. And then I will go up. Okay. So I will create another column here. Which are the corresponding ZI values. Okay. And these ZI values are minus, the first one is minus 1.838. What does it mean? That means to the left of minus 1.838, the standard Z-score is the area 0.033. The next one is minus 1.282. Next one is minus 0.966. Then the next one is minus 0.729. Next one is minus 0.525 to me. Next one is minus 0.3416. Okay. Next one is minus 0.1679. Next one is at 0.5. That means area in the left tail is the area of the left half. So the z-score will automatically be 0 at the center. Then we are on the right portion, and so we have positive values of z. 0.1687. Next one is 0.3398. Next one is 0.524. Next one is 0.7257. Next one is 0.966. Then 1.2815. And the last one is 1.838. 1.838. Okay. Okay, now what we're going to do. So let's move up a little bit. So now we can do two things. Okay. We can do, actually, let's change the color further. Let's use a dark green color. Okay. Okay. Let's move. Hello. Hi, how are you doing? Pretty good. Okay, I'll take a look and I'll take it questions like this. Yeah. And then, yeah, I'll take it. Thank you. So what we are going to do is use our calculator to make a plot the points as xi, zi. Okay, so that means we can enter the xi value in L1 in TI-84. So enter xi value in L1 and corresponding zi value in L2. Okay, let's do that. So let me take my calculator. Let me move a little bit up. So first I will enter the xi value in the calculator. So first I will clear the memories of the calculator. Second, plus button, then 4, clear all list, done. Then stat 1. In L1, you enter 102, 105, 113, 120, 125, then 127, then 134, 135, 139, 141, 144, 145, 149, 150, and 160. Okay, so these are my xi values from the second column. And then in L2, I'm going to enter the corresponding zi values. So the minus is next to the enter, 1.838, then minus 1.282, then minus 0.966, then minus 0.229. Okay. Is that correct? No, it should not be. Let me make sure that I have done it correctly. Oh, that's 729. Pardon me, that's a 729. So let me make sure everything is right. So this is 729. This one is 729. Okay. So minus points. So third one is minus 0.966. Next one is minus 0.729. Next one is minus 0.525. Then minus 0.3416. Then minus 0.1679. Then 0. Then 0.1687. Then 0.3398. Then 0.524, then 0.7257, then 0.966, then 1.2815, and the last one is 1.838. So I have xi values in L1 and the corresponding zi scores, the standard normal variable scores in L2. I'm going to make a plot of xi versus zi, xi on the horizontal axis, zi on the vertical axis. So I will press second button, then y equal to, and then number 1. Okay. So I can do a scatter plot. The first line should be on, second line should be scatter plot. My X list is L1 and my Y list is L2. This is just fine. Then I will do zoom 9. Okay, so let me show you, or let me try to reproduce the plot that I see in the screen. So if I go back here, you will see the plot is like this. So in your calculator, you are seeing a plot like this. Little bit of curvature in the beginning, but then it pretty much goes up like this. Okay, so this is xi on the horizontal axis and z score on the vertical axis. Okay, and pretty much the points fall on a single straight line going up the hill. Okay, all the points on the xi versus zi curve fall on a fall almost on a single line going up the hill, on a single straight line going up the hill, line going up the hill, up the hill. Okay, and the plot, okay, this plot is let me write it down. This plot is called normal quantile plot. Quantile plot. Okay. So if the points approximately follow a straight line, approximately follow a straight line, then the population may be from which the sample came, from which the sample came, can be treated as approximately normal, as approximately normal, which is true in our case. Okay, so this is the deal. So you make a normal quantile plot of xi versus corresponding z scores. If these points fall on a line, single line, then you can assume the sample came from a population which is approximately normal. Okay, and question is, why should they fall on a straight line? That I will write a few lines too. So let me move up a little bit. Why? So let me write down. Why do the points? So this point is called this plot is called a normal quantile plot. Okay. Okay. Why do the points on a normal quantile plot fall on a straight line when the population is normal? Is normal. If the population is normal, if the population is normal, if the population is normal, then on the average, the zi will be close to the actual z scores of the x. Scores of the x. Okay. And for any sample, the actual z-scores. Oops. Okay. Let me clean this up. So why do the points on a normal quantile plot fall on a straight line when the population is normal? If the population is normal, then on the average, um, Zi will be close to the normal z-scores of Xi. Zi will be close on the average, and then on the average the value. Let me clear it out. Then on the average, the values of Zi will be close to the actual z scores for the X. Okay, and for any sample, the actual z scores will follow a straight line. Straight line. When plotted against Xi. Therefore, if the population is normal, it is likely that the points Xi, Zi, Zi will approximately follow a straight line. Only thing I have to take care of is this one, which is normal. So against Xi. If the population is normal, comma, it is likely the points Xi, Zi approach. Why? Because the Zi values that we have calculated is very close to the actual Z-score. And if the population is normal, then the actual Z-score versus, so if you make a plot of actual Z-score versus X, they follow a straight line. Hence, because our calculated Zi is very close to the actual Z-score, so if the population is normal, the plot of Z versus X, or XY, ZI, XI on the horizontal axis, Z on the vertical axis, and the points will fall on a single straight line. Okay, so I'll stop here today. If you have any question or comment, write me a note. I'll get back to you as soon as possible. If you like this video, give me a hands up. I want to give you a tip. I always want to give you a tip at the end, right? So I hope you did not quit. So there's another easy way to do it, is to use the second y equal to function in TI-84, then number 1, we have entered the data in L1. Remember the xi values are in N1. So, so number 1 on, and then type, instead of doing a scatter plot, then scatter plot is the first type. Go to the sixth kind of plot, the last plot, and hit enter. That's actually a normal quantile plot. And immediately your data list will be L1. Then you do zoom 9, and you will see the same straight line plot that we just did. So basically what we did is available as option C in TI-84. Basically the TI-84 option 6 is a plot of CI on the vertical axis and XI on the horizontal axis. Okay, so that's it. That's the hint tip of the day. So we went through a lengthy process by dividing into 1 over 2n. Okay, and the first one got the value of 1 over 2n, and we put all the points in the interval from 0 to 1. We could have also done it by using the sixth kind of plot in TI-84. Anyways, it was nice talking with you. If you have any question, give me send me a email, and you just send me a note. I'll respond to you. And if you like this video, please give me a thumbs up. Please share this video with your friends. If you like it, you and your friends, please subscribe to my channel. I'll be back next time with another interesting problem, interesting solutions. Okay, thanks for watching. Take care. Have a nice day.